Hello everyone. In today's session, we will discuss reflection of light at curved surfaces. In 7th and 8th classes, you have learnt about the image formation in plane mirrors. You also discussed and learned the spherical mirrors also, like convex mirror and concave mirror, and what are the uses of these two mirrors. And also, why do we call the curved surfaces, like the curved surfaces, those mirrors, like convex mirror and concave mirror can be called as spherical mirrors. So why do we call this convex and concave mirror as spherical mirrors? Now we'll discuss in today's session. Dear children, now look at the pictures carefully, now one by one. The observation should be the size of the image here, how the image is formed here. Meaning you need to find either the image is inverted or the size of the image is same as the size of the image. All these things you have to observe here. Now look at in picture number 1. Look at this mirror. This is a curved surface. In this mirror, you see the size of the image formed in the mirror. Is this diminished or enlarged image? So here the size of the image is less than the size of the object, meaning it is diminished image. You may be familiar with this type of mirrors. You have been seeing these mirrors in day-to-day life. You have been observing. This is nothing but a rear view mirror, which is used in the vehicles to observe the vehicles or passing objects which are passing beside the vehicles. You see, in these two mirrors, how the size of the image is. Is it diminished image or enlarged image, or the size of the image equals size of the object? Absolutely, the right answer is the size of the image is less than the size of the object. See here, in these two mirrors, you observe that the size of the image is less than the size of the object. Whereas if you see in this mirror, you see, have you seen this type of mirror in day-to-day life? ఇలాంటి మిర్రర్ మనం చూస్తే ఎక్కడ చూస్తుంటాం? జనరల్గా ఇఫ్ యూ గో టు జ్యువెలరీ షాప్ కానీ లేదంటే మన ఆప్టిషియన్స్ అంటే మన స్పెక్స్ వెళ్ళినప్పుడు అక్కడ ఇలాంటి మిర్రర్స్ ఉంటాయి మనకు. సో డూ యూ థింక్ దిస్ మిర్రర్స్ ఆర్ ప్లేన్ మిర్రర్స్? No, absolutely no. These are not plain mirrors. Though they seems to be plain mirrors, they are not plain mirrors. They are spherical mirrors. Strictly, they are concave mirrors. They are concave mirrors. You see here, the size of the image, though the photograph is not right, but the size of the flower, the size of the flower should be the enlarged one than object here. See, it is visible the size of the image is diminished as you see, but the concave mirror always forms enlarged image. Remember this. So these two mirrors are curved surfaces. They are spherical mirrors. Now let me tell you why do you call these mirrors are spherical mirrors. Now look at the one more picture here. Now what do you seeing this? What is this? This is a sphere. This is what? A sphere. Now imagine అంటే మీ ఇంట్లో ఒక బిందె, అంటే మన వాటర్ పట్టుకున్న బిందె, స్టీల్ బిందె ఉంటుందో దాని యొక్క సరౌండింగ్ చూస్తే ఇఫ్ యూ అబ్జర్వ్ ద స్టీల్ వెజల్, యూ కెన్ సీ ద ఆబ్జెక్ట్స్ ఇన్ దట్ వెజల్, ద సైడ్ ఆఫ్ ద వెజల్. And now this is nothing but acting like which mirror is convex mirror. Which mirror? Convex mirror. When you see from the outside, you can see it is as a concave mirror. Now suppose let assume yourself you are in this sphere. At the center of the sphere, if you see the walls of the sphere, in the center, with respect to the center of this sphere, if you see, Let assume your position at the center of the sphere. If you observe the walls of the sphere, the walls is nothing but they are concave mirror. They are concave mirror. This mirror you can see from outside. So what is my intention is this either convex mirror or concave mirror. They part of a sphere. If you cut a sphere, it may become convex surface or concave surface. Depending upon its coating, it acts as a convex mirror or concave mirror. Now in this chapter we'll discuss reflection of light at curved surfaces. Now you got a point what are the curved surfaces means here. Okay. Now when does reflection take place? When does? So for the reflection of light, the obstacle should be opaque medium. It should be opaque medium. It may be rough surface, it may be plane surface. That is scientific terminology. It may be regular surface or irregular reflection. Maybe regular reflection or irregular reflection. Regular reflection takes place when the light is incident on a smooth opaque surface. Irregular reflection takes place when the light is incident on the rough surface. Okay. You all discussed, you all learned all these things in the lower classes, but reflection will takes place whenever light is incident on opaque surface. So now curved surfaces are here opaque surfaces. The example for the opaque surface are mirrors. Now which type of mirrors are here? They are curved mirrors. Now which mirrors we are discussing in this chapter? We are going to discuss convex mirror and concave mirror. Okay, so let me go for a basic terminology in these mirrors. So children, now look at the how concave mirror and convex mirror are represented. So don't be confused the how they are bending. Okay, you have to look at the where the reflection is taking place. We can also draw the concave mirror like this. We cannot decide whether this is a mirror or not. So unless there is a coating, so with respect to coating only, silver coating, it may be silver coating or aluminum coating, we are going to decide the type of the mirror. ఒకవేళ సిల్వర్ కోటింగ్ అనేది ఇలా ఈ సైడ్ సిల్వర్ కోటింగ్ ఉందనుకోండి, ఇలా సిల్వర్ కోటింగ్ ఉంటే ఇప్పుడు రిఫ్లెక్షన్ ఎక్కడ జరుగుతుంది? సో డెఫినెట్గా రిఫ్లెక్షన్ అనేది ఇన్సైడ్ జరుగుతుంది. Now in this side we can see there is a reflection of the light ఇక్కడ రిఫ్లెక్షన్ జరుగుతుంది. కాబట్టి ఇది కాన్వెక్స్ మిర్రర్, మళ్ళీ ఇదే మిర్రరు. వాట్ ఈస్ ద నేమ్ ఆఫ్ దిస్ మిర్రర్ అంటే డోంట్ బీ కన్ఫ్యూజ్. వీ కెనాట్ డిసైడ్ ద ఇన్ విచ్ డైరెక్షన్ ఇట్ ఈస్ బెండింగ్. వీ కెన్ డిసైడ్ ద టైప్ ఆఫ్ ద మిర్రర్ based on is silver coating or aluminum coating and where the reflection is taking place. Okay, so we can also draw concave mirror like or like this. Okay, don't be confused. We can decide either a mirror is convex or concave mirror based on its reflection. Okay, based on where the reflection is taking place. So concave mirror bent inwards, the reflection is taking place inside here from this side. Okay, so that's why concave mirror is bent inside. But whereas if you see the concave mirror, it is a convex mirror. If you see, I can also draw the convex mirror like this. Now tell me where the reflection is taking place. The reflection is taking place definitely opposite the silver coating. Now this is silver coating. Now reflection will takes place in the outside. In the outside reflection takes place, meaning at the side of the blue color you can see here the reflection will takes place. Suppose the light is falling on the mirror, it will reflect like this. Okay, meaning convex mirror is bent outwards. Okay, so don't be confused. You can decide whether the mirror is convex or concave mirror based on the reflection surface. Okay, have you got it? Children, what I told is either convex mirror or concave mirror is part of the sphere. Okay, so let now imagine the center of the sphere. This is center of the sphere, this is center of the sphere. Okay, now the center of the sphere can be called as center of curvature of the curved surface, a spherical surface. Center of the sphere can be considered as center of the curvature of the spherical mirror. It may be convex mirror, concave mirror. So center of curvature is nothing but center of the sphere for which a spherical mirror belongs to. Then how to find a center of curvature for the spherical mirrors? For that you have to do is a small activity. Now look at now. Take a small piece of thin foam or rubber. It may be anything. I am taking a rubber foam. For that I am inserting the nails, sharp nails, perpendicular to the. These nails are perpendicular to the this rubber foam, and after that what I am doing, just I am bending inwards like this shape. When I am bending like this, what happens, all this will come to close, all these nails will come to close. Now this is nothing but convergent all these nails. Now what do you call this point to this curved surface? What do you call this point to this curved surface? Is nothing but center of curvature. It may be inside, it may be outside of the mirror. For convex mirror, it is outside. But whereas the concave, it is inside. Okay, so what are we doing? Simply we are taking a rubber foam, and for the rubber foam you are inserting the iron nails, the sharp nails perpendicular to the foam. You are bending, it may be outside or inside. Suppose we bend the inwards, all these nails will meet at a particular point. That point I can call as center of curvature. If you bend the outside, they may be divert. They are divergent like this. If you bend like this, all nails will move away from to each other like this. But if you extended them, all this will meet at a particular point. Okay, now this is the center of curvature. If you draw a line from center of curvature to the surface of that curved surface of the curved one, so you will get a normal line. Normal line. Now let me draw a curved surface. This is the curved surface. Now what do you call this? Can you call this as a mirror? No, definitely no, because ఇది mirror and decide చేయాలంటే నీకు కంపల్సరీ ఏం కావాలి? కంపల్సరీ you have to decide and which side the silver coating is there. Now tell me, now what do you call this? This is nothing but a convex or concave? It is concave mirror. Now for this concave mirror, you see there is a geometrical center for this. అంటే let assume the curved surface యొక్క లెంత్ వచ్చేసి circumference వచ్చేసి 4 centimeters అనుకున్నప్పుడు దీని యొక్క మిడ్ పాయింట్ ఎక్కడ ఉంటుంది నాన్న? మిడ్ పాయింట్ విల్ బి at the 2 centimeters, at the 2 centimeters, meaning exactly there will be one mid point. Geometrical center, the geometrical center of the curved surface is called pole. What? Pole. Geometrical center of the the geometrical center of this curved surface is called pole. Okay, now if you draw a line, an imaginary line from pole to center of curvature. Center of curvature can be represented with the symbol C. It is P. From pole to center of curvature, if you draw a line, now tell me what do you call this line? This line is called principal axis. What do you call? Principal axis. This is an imaginary line which is passing through the pole to center of curvature. Pole to center of curvature. Okay, dear students, next is what do you call PC? Now what do you call the line segment PC? What do you call the line segment PC? The distance between pole to center of curvature. What do you call this distance? Can you tell me what do you call this distance? This is nothing but radius of curvature. What do you call? Radius of curvature. Radius of curvature. Radius of curvature. Okay, now next, just a minute. Now radius of curvature is represented with symbol R. With symbol R. Okay, radius of curvature is represented with the symbol R. What about the pole? P. What is the center of curvature is represented? C. Remember, center of curvature is nothing but the center of the sphere for which a spherical mirror is belongs to. What is the pole? Pole is nothing but the geometrical center of the curved surface. Is nothing but midpoint of the curved surface. Now what is the principal axis? Principal axis is nothing but an imaginary line which is passing through the pole to center of curvature. Now what do you call this line segment? The distance between pole and center of curvature is called radius of curvature. Now look at the look at here, all of you look at this diagram. The first diagram, you see in this diagram, now there is a dotted lines. Now what does this dotted line represent? Now if you draw a line from center of curvature to center of curvature to center of curved surface. సెంటర్ ఆఫ్ కర్వేచర్ నుండి కర్వ్డ్ సర్ఫేస్ మీదకి ఒక లైన్ డ్రా చేస్తే ఈ లైన్ మనం ఏమంటున్నాం? నార్మల్ లైన్ అంటున్నాం. ఏమంటున్నాం? నార్మల్ లైన్. ఏమంటున్నాం? నార్మల్ లైన్. సో ఇఫ్ యూ డ్రా ఏ లైన్ ఫ్రమ్ సెంటర్ ఆఫ్ కర్వేచర్ టు కర్వ్డ్ సర్ఫేస్, దట్ లైన్ is called normal line. This both are normal lines only. Okay. Now next is, look at the next diagram. Now can you tell me what do you call these two mirrors? What do you call these two mirrors? Are these two mirrors convex mirror, concave mirror? Definitely they are concave. They are concave. Why? Because the reflection is taking place inside, not outside. Okay, the reflection is taking inside. Inside is the reflection taking place. The silver coating is outside. Where the silver coating? The silver coating is outside. This is a silver coating. This is the silver coating. This here the silver coating is. Okay. Now next, children, what is the use of to find the normal line? Okay. You see, now tell me what is the loss of reflection? Loss of reflection. Loss of reflection. First one is angle of incident equals to angle of reflection. What is the angle of incident means? The angle between incident ray and normal. Now this is the angle between incident ray. This is the incident ray. Now this is the normally dotted line represents. This dotted line represents normal line. The angle between incident ray and normal is called angle of incident. The angle between reflected ray. This is the reflected ray. The angle between reflected ray and normal is called angle of reflection. Okay. Now, so further to find the angle of incident and angle of reflection, we required a normal line. Okay. Now second one is incident ray, reflected ray and normal will lie in the same plane where the light is reflected, incidented. So these are the laws of reflection. Now my question is laws of reflection is valid for the curved surface? Are the angle of reflection and angle of incident also equal for reflection by curved surfaces? Absolutely yes. Okay, curved surfaces also obeys laws of reflection. Remember, the light always follows laws of reflection while reflection is taking place. Okay, light ఎప్పుడు కూడా ఏ లాస్ని ఫాలో అవుతుంది? లాస్ ఆఫ్ రిఫ్లెక్షన్ ఫాలో అవుతుంది. ఎప్పుడు రిఫ్లెక్షన్ జరుగుతున్నప్పుడు, అది ప్లేన్ సర్ఫేస్ అయినా కర్వ్డ్ సర్ఫేస్ అయినా, ఇట్ మే బి కర్వ్డ్ సర్ఫేస్ ఆర్ ప్లేన్ సర్ఫేస్, light always follows laws of reflection during reflection. Okay, now in this chapter we'll discuss the main characteristics of the convex and concave mirror, how these two mirrors are behaving. So let me discuss one more point regarding what is the focal point, what is the focus. Okay, dear student, now look at the picture number 2b, how this diagram is. Now what is the name of this mirror? It is concave mirror. There should not be any doubt here. Okay, now the light ray, incident ray is, this is the incident ray. How the incident ray is parallel to the principal axis. What is the principal axis? The imaginary line which is passing through the pole and center of curvature. This is the principal axis. Okay, now these two rays are parallel to each other. Now the light as incident on the curved surface and reflected through a particular point. Okay, particular point. Let me do an activity. What happens if you keep a concave mirror in front of sunlight, or where the abundant light rays are available? Okay, now let me see how concave mirror behaves. So dear students, what you are doing in this activity, we are holding a concave mirror such that the sunlight falls on it. Okay, now for that, and after holding your concave mirror in front of the sunlight where the abundance of sunlight is available, now take a small paper and slowly move it in front of the mirror and find out the point where you get the smallest and brightest spot, which will be the image of the sun. You see here where the image of the sun you are seeing. Now look at here, all light rays are parallel to the principal axis. They are, after reflecting, they are passing through a common point. This is a common point. You can see the pink color is a common point. If you hold a paper at the pink color here, what happens? The paper will be burnt. Okay, now all these incident rays are meeting at this particular point. That point is called focus. What do you call? Focus. It's called focus. Okay, now this is the way how to find the focus of a concave mirror experimentally. A small activity. Now what is the light rays are behaving here? When the light rays are parallel to the principal axis, they are converging, they are passing through a common point. That point is called focus. Okay, now what do you call the distance between this pole and focus? the distance between pole and focus is called, what do you call, focal length, is called focal length. Remember, focal length is different, focus is different. Capital letters, capital F is used to represent focus, whereas small f is used to represent the focal length. Okay, now the distance between pole and focus is called focal length. Okay, the next thing is, what is the relationship between radius of curvature and focal length? Radius of curvature, you know, it is R, capital R, focal length, focal length. Now once all of you, just a minute, look at here, all of you look at here. Now the distance from P to F is equals to the distance between F to C. F is focus, C is center of curvature, P is the pole. పోల్ నుండి ఫోకస్కి ఎంత దూరం ఉంటుందో ఫోకస్ నుండి సెంటర్ ఆఫ్ కర్వేచర్కి అంత దూరం ఉంటుంది. అంటే మన పోల్ నుండి ఫోకస్కి మనం ఏమన్నాం, ఎఫ్ అన్నాం, అంటే ఫోకల్ లెంత్. మళ్ళీ ఏమవుతుంది, ఫోకల్ లెంత్ అవుతుంది. మళ్ళీ పీ టు సి, వాట్ యు కాల్ పీ టు సి అంటే రేడియస్ ఆఫ్ కర్వేచర్ కెన్ బి రిటెన్ ఎఫ్ ప్లస్ ఎఫ్, పీ టు ఎఫ్ ప్లస్ ఎఫ్ టు సి. దేర్ఫోర్ ఆర్ ఈక్వల్స్ టు 2f, r equals to 2f. Okay, dear student, here we got the image of the sun at focus. Okay, now my question is, do we get an image with a concave mirror at the focus every time? Is it possible? So we'll discuss in the next class. Now where the image, different object distance, different image distance. Now what is the constant here? The focal length will be constant, which cannot be changed.